Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Latent Space presents Dex Horthy, founder of HumanLayer. His central thesis: viral frameworks are architectural traps, and true production reliability requires deliberately capping your context window at 40%. These aren't speculative opinions, they're engineering principles extracted from observing the hidden practices of elite AI teams. Dex Horthy is the founder and CEO of HumanLayer, a YC-backed company focused on helping engineering teams ship reliable code with AI. He gained recognition for popularizing context engineering through widely shared technical talks. His engineering credentials trace back to an unusual starting point. At 17, as a high school intern at NASA's Jet Propulsion Laboratory, he built a pathfinding system for hypothetical lunar rovers navigating steep craters at the moon's south pole to locate ancient ice. That early experience with mission-critical problem-solving established the foundation for his current philosophy on building dependable AI systems. The current AI landscape presents a paradox. Open-source frameworks and indie hacker stacks promise to build agents in minutes, yet Dex argues there exists a massive, invisible wall separating the top 1% of engineers from everyone else. The tools dominating public discourse optimize for what he calls vibes, impressive Twitter demos, where an 80% success rate feels acceptable. Real enterprise engineering, the kind companies pay six figures for, demands an entirely different architecture that remains hidden from public view. His reasoning centers on misaligned incentives. The vibe coding community prioritizes speed and flashiness, frequently producing what Dex terms slop derivative, low effort implementations. Meanwhile, the top 1% ignore popular frameworks entirely, constructing custom deterministic guardrails to ensure reliability. This inverts the typical open source ethos, suggesting that in the AI era, the most widely adopted tools may actually hinder anyone attempting to build serious software. Dex's path to this conclusion has a revealing origin story. While developing tools for AI engineers, he observed that elite teams were building agents in ways that diverged completely from public open source demos. This observation led him to write an exhaustive 1-2 chapter guide. In a classic case of signal emerging from noise, only one chapter, the one addressing context engineering, resonated with the community and went viral, crystallizing the narrative he champions today. Transitioning from industry-wide observations to specific engineering tactics, Dex introduces a constraint regarding context windows that defies common intuition. We currently witness an arms race where models offer 1 million, 2 million, even 10 million token windows. The natural instinct is to maximize this space, stuffing in as much data as possible to give the AI perfect context. Dex rejects this approach for the majority of developers, introducing what he calls the dumb zone. He recommends that unless you possess deep, expert-level intuition, you should artificially cap yourself at using only 40% of the context window. While models can ingest massive amounts of data, their reasoning capabilities become brittle and unpredictable when the window is saturated by a novice. A good trajectory with less data often outperforms a model with perfect information that is overwhelmed. This constitutes a form of engineering heresy, deliberately underutilizing the most expensive and touted feature of modern AI to increase reliability. The host asked how Dex discovered this dumb zone, and his response added a layer of relatability to the technical concept. He simply laughed, admitting he knows it so well because he has spent a lot of his life there. That moment of humility transforms his counterintuitive advice from a lecture into a hard-won lesson from the trenches. This constraint naturally raises the question, how does one bridge the gap between novice and that top 1%? You might expect a specific curriculum, a textbook, or a coding boot camp. Instead, Dex prescribes a brute force method that sounds almost absurd. Talk to Claude for 70 hours a week. He believes context engineering isn't a technical skill you learn syntactically. It is a muscle memory you build through massive exposure. He compares it to a mind-model connection, similar to a gym workout. You have to physically feel the model fail hundreds of times to develop the intuition for what is possible. This redefines AI engineering from a knowledge-based profession to an intuition-based craft, closer to art or athletics than traditional computer science. Far from being flippant advice, this recommendation reflects Dex's own practice. He revealed that he personally talks to AI models like Claude for roughly 70 hours a week. He is putting in the reps he preaches, treating AI not just as a tool to build with, but as a system to build a relationship with. Next, Consider a logical inversion regarding the evolution of AI models. The standard assumption holds that as models like GPT-5 or Opus 4.5 get smarter, the need for prompt engineering or context engineering will disappear because the model will just get it. Dex argues the opposite. When smarter models were released, many DevOps engineers claimed, finally, we don't need to engineer the context anymore. However, Dex points out that the best engineers were already achieving those superior results with the older, dumber models because they put in the work. Smarter models don't solve the engineering problem. They simply move the frontier of possibility outward. There will always be a boundary where the model only kind of works, and the job of the engineer is to live on that edge and make it reliable. If you stop engineering because the model got smarter, you are merely settling for the baseline performance that everyone else has, rather than unlocking the model's peak potential. Dex's own career trajectory illustrates this evolution. He described how he transitioned from spending all his time coding to leading workshops and whiteboarding sessions with customers. His focus shifted to helping teams actually ship code with AI, and he even brought on a stronger technical co-founder to own most of the core engineering. It's a personal illustration of an engineer moving up the value chain from pure implementation to strategy and enablement. Finally, Dex presents a shift in the definition of a software engineer. For decades, the identity of a coder was someone who writes syntax in a text editor. Dex contends that this definition is obsolete. The role is shifting from writing code to causing working code to be produced. He distinguishes coding from shipping. Coding is making software work on your local machine, a task AI is becoming exceptionally good at. Shipping is getting that software into production, maintaining it, and handling the complex, messy edge cases of the real world. The future engineer isn't judged by lines of code written or even by their technical fluency, but by their ability to orchestrate AI agents to deliver a reliable product. The human becomes a manager of digital labor rather than a laborer. Dex's own story proves he lives by this shipping ethos. At a previous company, he started as a pure engineer, but when the sales leadership turned over, he didn't just stay in his lane. He jumped into a customer-facing role and personally closed about 12 enterprise deals in just 3 months. It's a powerful example of someone who understands that the ultimate goal isn't elegant code, but a product in a customer's hands. Coding is like making the software work. Shipping is like getting it into prod and maintaining it over time. If you're interested in the video featured in this episode, click the link below to watch the original.